Greetings guys, this is Mark 9 Mass Lectures Online. We continue with electrical trade theory and two transformers. Here we've got a question which says a 400 kilovolt amps 2200 400 volt 3-phase transformer is delta connected. Calculate 1. The primary phase voltage, 2. The secondary phase voltage, 3. The transformer ratio, 4. The primary line current, 5. The primary phase current, 6. The secondary line current, 7. The power delivered on full load if the power factor is 0.75 lagging. Express your answer in kilowatts. Let's try to answer those questions. It's a 3-phase transformer, and we are told that it's star delta connected, and we are given apparent power as 400 kilovolt amps. V line 1 it's 2200 volts. V line 2 is 400 volts. And then number 1, we are told to calculate the primary phase voltage, since it's a Y and we know that the V line is across two windings. To get V across one winding, which is phase voltage, it's going to be V phase 1 equals to V line 1 over square root of 3, and that will be 2200 over square root of 3. 2200 over square root of 3 equals to 1270.171 volts. Number 2 says the secondary phase voltage. This is delta, and we know that V line is across a winding, and V phase is across that very same single winding. So V phase 2 equals to V line 2, which is equals to 400 volts. Number 3 says the turns ratio N1 over N2 equals to VP1 over VP2, which is 1270.171 all over 400. Divide this by the smallest. 400 into 400, it's 1. Then 1, 2, divided by 400 is 3.175. So our ratio is 3.175 is to 1. Then number 4 says calculate the primary line current. To do that, we'll use the apparent power formula, which says apparent power equals to square root of 3 V line 1 I line 1, making I subject of the formula I line 1 equals to S over square root of 3 V line 1. Substitute what we are given as 400,000 all over square root of 3 V line 1 is 2200, and we get 400,000 over square root of 3 times 2200, 104.973 amps. So I line 1 equals to 104.973 amps. And then number 5 says the primary phase current. The primary side, if you check the line current, the current coming through this way, it also passes the first winding, so it's the same throughout that single phase. So I phase 1 equals to I line 1, which is 104.973 amps. Then number 6 says calculate the secondary line current. We'll do the same thing using the apparent power formula V line 2 I line 2. I line 2 equals to S over square root of 3 V line 2. Substitute what we are given. It's going to be 400,000 over square root of 3, and line 2 it's 400. Square root of 3 times 400. You get 577.35 amps. So I line 2 equals to 577.35 amps. And we can also use I1 over I2 equals to N1 over N2, which implies that I phase 2 equals to, oh no, this N2 over N1, which implies that I phase 2 will be N1 over N2 I phase 1. Substituting what we get, I phase 2 equals to N1 is 3.175, N2 is 1 times I1, which is 104.973, 3.175 times 04.973. That gives us 333.289 amps, and therefore I line 2 equals to square root 3 I phase 2. It's square root of 3 times 333.289. This is equals to 577.274 amps, which is almost the same as this one. And then the last question, which is number 7, says the power delivered to the load on full load if the power factor is 0.75. We know that power factor equals to P over S, and then we need P. So P equals to S times PF, and our S is 400,000 and our PF is 0.75, and we get 400 times 0.75, we get 300 kilowatts. And that's it for this transformer question. Thanks for watching Magnanimous Minds lectures online. Please do subscribe to our channel as well as liking our videos. Also do follow us on our social media pages. On Facebook we are Magnanimous Minds with a Z, Instagram Magnanimous_Minds with a Z, Twitter at Magnanimous Mean1, Mean1 spelled as MIN1 as a digit. Thank you.